Ciao friends, and welcome to a new video from SQL BI. In this video, I want to show you exactly what happens when you use a measure in a matrix as a filter rather than as a value. We typically use measures in a matrix because we want to see their values, so we use it in the values area. But sometimes we use a measure only to filter the rows, because we want to reduce the number of rows that are visible in the matrix itself. Now, it turns out that there is a subtle difference between using a measure as a filter when the measure itself belongs also to the values of the matrix, or when you use the measure only as a filter. I recently discovered this behavior while answering to a question on one of our forums, and at the end of the video that describes that solution, I thought that it was worth writing an article and a video with a simpler scenario, because in that video, when I discovered the problem, the scenario was rather complex. Therefore, we are now going to build a much simpler scenario. Then we use a measure as a filter, we face the problem, and finally we fix that. This is not the kind of issue that you will find very easily or very often, because it requires several pieces to be in place to show up. With that said, that is also the kind of problems that when and if you ever face it, you will be glad that you have seen it before, because investigating on it takes some time. With all that said, let's get started. As I said, we need a simple scenario. That is why we are not going to use our complex Contoso model. Instead, we use a much simpler model that only contains product, sales, and data. And we just have a small set of products. We have apple, pear, and banana, with some sales in 3 years, 2010, 2011, and 2012. Now, you see that Apple is our bestseller. It sold $1,000 over all time, so it is our bestseller. Second comes pear, and finally banana. Of course, the selection of which is the best depends on time. Indeed, if we filter only 2011, you see that Apple goes at the bottom, because now pear is the bestseller. Out of this report, I want to create another report that shows the top two. So what I want to do is create a report that only shows the top two bestsellers depending on the selection made by the user. So if the user selects 2 years, I want the top 2 in those 2 years. That requires us to build a ranking measure that will rank the products from the best to the worst, and then a filter that restricts the visual to only the first 2 products. So let's get started writing the ranking measure, then we apply the filter, and only then we will be able to see the problem. The first thing that we need is the ranking measure. I already have it here, but I think it's worth starting from scratch and write it together, so you see the entire process. So we need a measure that ranks the products based on the sales amount. We call this measure ranking, and the measure needs to compute to find all the products that are selected. So we save in a variable all selected, where are you? All selected product, and then we compute the ranking. The ranking uses rankx over the products, and then we can use calculate. We could use just amount, which is the sum of sales amount, but we do not want the ranking to be local to the current year. We want the ranking to be over all time. So we can use calculate amount, and we use remove filters over date. And finally, return ranking. So my ranking measure should write 1, 2, 3, ranking correctly our products. Let's try to use it in the report. I place it here, and it shows 1, 2, 3, 1, 2, 3, 1, 2, 3. We have this number 1 here at the bottom that we do not want. So let me get rid of it by using has one value, product, so that we do the ranking only if there is only one product visible. And now we got rid of the one at the bottom. Still, the measure is not correct because it uses remove filter here, and because it uses remove filter, it will not fill a filter coming from the slicer. You remember in 2011 Apple was third, but if we select only 2011, Apple is still first because remove filters got rid of any filter. So we cannot just use remove filters here, we should use all selected. By using all selected, we restore the filter on the slicer, and that will compute the correct ranking. Let's give it a try. Now you see that Apple, if I select only 2011, goes at the third place. If I select 2012, goes at the first place, and if I don't select anything, again, it goes at the first place. Now, this was the first step. The next step is to limit the number of rows visible to only the 2. And we can achieve this goal by applying a filter on the visual that shows only the rows where the ranking is less or equal than 2. Let's do that. We open the filter pane, select the visual, and we say that for the ranking we want all the values that are less than or equal to 2. We apply the filter, and now you see that we only have apple and pear. If we select 2011, we have pear and banana, because all selected takes care of removing the filter from the year which is in the current visual, but still keeping the filter which is coming from the report. Now, everything looks fine so far. But if we select, for example, 2010 and 2011, we have pear as the first place and then apple. We do not want to see the ranking. The ranking is useful only for the filter. We do not want to see the ranking in the report. What happens if I get rid of the ranking? Let me reduce that, get rid of the ranking, and you see that now I see 3 rows, apple, banana, and pear. Whereas if I place the ranking in my matrix, I see only 2 products, apple, apple, and pear. Therefore, it looks like, depending on whether the ranking measure is in the visual or not, the values are different. Let me show you that again. I remove the ranking, I have 3 rows. I add the ranking, I have only 2 rows. Now, it turns out that the behavior of the DAX engine depends on the usage of the measure. If you use a measure as a filter, then the DAX engine needs to apply the filter. If you also use the measure as one of the values, the way the filter is computed is slightly different. Indeed, Power BI needs to perform 2 operations. First, it needs to find the products that satisfy the filter condition, and only later it will compute all the values. To do that, it executes the query in a quite complex way. So, in order to understand exactly what happens, we will need to investigate on the query, understand exactly how the values are computed, and then face the problem of arbitrarily shaped filters used as a filter in summarized columns along with all selected. That is kind of tricky, so we will need to investigate on the code and understand it really well. Let's do that. Let's get rid of the ranking because we want the problem to appear. And then we go in View, Performance Analyzer, and we look at the query. So start recording, analyze this visual. We have the matrix and the query that has been executed. I just copy it in the clipboard, and then we launch DAX Studio to look at the code. Let's paste the code here. Then we format it to make it more readable, and here it is. We can get rid of those because we need a bit more space. Okay, let's look at the query together. We have a first filter that is the slicer, 2010 and 2011, that are the 2 years that we have filtered. Then we have this variable that does a summarize columns by product, year, and then uses the slicer as a filter here. And it computes the amount. What is the content of this variable? We can copy it and return it to see its content. This contains the product, the year, and the amount, which are the same values that are shown here. The reason why this variable is computed is because the engine wants to know in advance which combinations of product and year actually have a value for amount, so that it avoids computing further values if a combination of year and product does not lead to any result that needs to be shown in the matrix. So once this variable is computed, it is then used in the next step, that is this filter. This filter summarizes by product, and it uses the slicer as a filter, and the variable that we computed earlier, this variable, the one shown here. This variable is used as a filter in order to avoid computing the ranking for combinations that would not produce any result. And then it filters only the rows where the ranking is less or equal than 2. Now let's see the content of value filter dm1. We can run that, and you see that the content is apple, pear, and banana. And both apple and banana, they have both a ranking of 2, whereas pear has a ranking of 1. Therefore, apple, banana, and pear all survive the filter, even though if we look at just the matrix and we put the ranking, and we also need to remove the filter for now, so let me use 5 here just to show the value. You see that banana have a ranking of 3. So if I look at the matrix, banana has a ranking of 3. But if I look at here, banana has a ranking of 2. Therefore, it survives the filter, which is kind of strange. Now, let me go back here and restore the scenario. It was with 2, and we didn't have ranking. So we have a banana here that should not be shown. But it is there because when it is evaluated in the second variable here in value filter dm1, it has a ranking of 2. Why that? Well, in order to understand it, we need to understand exactly what happens inside the evaluation of sales ranking. So let me search for sales ranking and define this measure. And then we get rid of it. Sales ranking has this if statement that we have seen earlier, then computes all selected product, and then uses calculate amount all selected data. What does all selected do? Well, all selected, when used inside summarize columns, all selected removes any filter in the group by columns, and it restores the filter context that was present when summarize column started, considering the outer filter context plus the filters that have been added as explicit filters in summarize columns. So in order to understand exactly what is restored by all selected, we need to investigate on the filters that are activated by summarize columns. Let's do that. This all selected restores the filter on data, and this is the summarize column we are working with that has a filter on the slicer. That filter is on the slicer and it's retrieving 2010, 2011 and 2010. So let me write it here. That contains 2 years, 2011 and 2010. Is it the right place? No, it is not. Yes, it is. Filter, second filter. Okay. Here it is computing 2010 and 2011, and then it's using value filter constraint, which is the table computed here. What are the years visible here? Well, that depends on the product, because if we retrieve again our first variable, you see that the year depends on the product. It's probably easier if we sort order by product. When Apple is selected, we have 2 years, 2010 and 2011. When pear is selected, we have again 2 years, 2010 and 2011. But in the very specific case of banana, we have only 2011. And it turns out that the banana is the row that appears here, the one for which we compute the wrong ranking. So when we are here, for the specific case of banana, we have only 2011. Therefore, the intersection of these two filters in the case of banana produces only 2011. And in 2011, let's look at the data here. If we only restrict everything to 2011, banana turns out to have a ranking of 2, which is correct. So the problem is that if you use a measure only as a filter, it is not considered as part of the measure in the definition of the rows that needs to be considered. Therefore, the set of years, in our case, that is returned might be smaller, and this computes the value in the wrong way. Look what happens if ranking is not only in the filter, but it is also in the value area. So we select 2010, 2011, we still have this less or equal, and we add the ranking here. Now it's behaving correctly. We only see 2 rows. Let's look at the code that is executed. With performance analyzer, start recording, analyze the visual, look at the code, copy the query. We do that in a new panel. And you see that when we compute value filter constraint DM1, we do not have only amount, we also have ranking. We have ranking here, and we do not have it here when we compute the measure, when we compute the filter in the case where the measure is used only as a filter and not as a value. And that is the reason why we have only 1 year here, whereas if we retrieve the value in the next query, we have for banana 2 years, 2011 and 2010, because ranking has a value of 3 and 3 in both places. So the fact that there exists at least one measure with a non-blank value makes 2 years visible. Therefore, having 2 years visible, we have both years and the calculation happens the correct way. Therefore, what we need to do in order to solve the problem depends on the specific calculation that we face. So far, we understood where the problem is. Solving it depends. It really depends on your specific business requirement. But our goal is that of forcing all the years to be visible during the execution of the first query, so that they will be visible during the execution of the second query, where the ranking is actually computed. Either you add a measure to your matrix so that you force the value to be present, or in our case, what we can do is to return 0 instead of blank for the sales amount measure. If sales amount, instead of returning blank, returns a 0, as a result, the first query will contain the combination banana 2011 with a sales amount of 0. 0 is not blank, therefore the row will be returned and the calculation should happen the correct way. Let's give that a try. What I need to do is only go here in the on Power BI, go to amount, And instead of returning only sum of sales amount, we return sum of sales amount plus 0. By changing the measure, we can now look at the original query. Remember, we have only banana 2011 with 350 in the case that is the previous execution. But if I run the code now, we now have banana 2010 with 0. What matters to me is that we have both years present in the result. And because we have both years present in the result, if I now retrieve the result of value filter dm1, we only have apple and pear, because banana will have a ranking of 3. We can check that by returning true here instead of the ranking, and you see that banana now has a correct value of 3. Finally, we can check that in the report. Now that we changed the measure, it is working with the ranking measure. We can get rid of the ranking, and it is still working. It works if I select 1 year, all the time, 1 year, 1 year, 1 year, or a combination of years. As I said, the important topic about the video is not specifically how to solve the problem. In this specific case, we decided to use +0 here in order to force the visualization. The important part is that there is a difference between using a measure only as a filter or using a measure both as a filter and as a value in a matrix in Power BI. So, as you have seen, the video was quite intricate. We needed, first of all, to understand the problem, then to investigate on the different queries that are being executed, and finally find the solution. The value is not in the solution. The solution really depends on your specific requirement. But if you ever face such a scenario, so a measure that acts in a different way or that changes the result of your code when you use it only as a filter or both as a filter and as a value, well, you know that you need to search for this optimization of DAX. DAX executes this optimization in order to reduce the number of calculations that needs to be executed. Instead of computing the ranking for all the possible combinations, it restricts it to only the combinations that have a value. But in order to determine the value, it uses the measures that are present in the report itself, ignoring measures that are used only for filtering. As a consequence, you might face this issue, and at least now you know where to search in order to debug your code and find a good solution. Enjoy DAX!